I just had a pretty nice idea, or rather a realization, about how awesome baths are. Specifically, I'm talking about baths in chemistry. For example, you might have some big flask and you have some sort of container in which you have some liquid, very often water, and then you have a heating element heating the water. Now, why do you do this? Well, basically, this gives you a lot of control of the temperature that the chemicals in the flask will be exposed to. If you have a heating element that works by, let's say, pumping electricity through some sort of coil that has high resistance and therefore heats up, like on an electric stovetop, then it's very difficult to determine what is the temperature of the surface of that heating element. In principle, of course, you can determine it by, for example, looking at how much infrared radiation is emitted or something like this. But if you use the heating element to heat the bath of water, you can simply stick in a thermometer and read off the temperature. And a thermometer is a much simpler instrument than some sort of analysis device that looks at what radiation is emitted. And in any case, this looking at what radiation is emitted might not even work if your coil isn't very precisely manufactured. Maybe there are sort of, at certain points it is thicker and other points it's thinner. Maybe the material at certain points has a slightly different composition such that the temperature is not uniform across the coil. If you instead have the water between the heating element and the chemical, then the water can act as a sort of temperature buffer. It's pretty easy to make it such that all of the water will have basically the same temperature. And in part, this is, if we're using water as the chemical for the bath, that water has a very high heat capacity. That means it can absorb a lot of energy in form of heat before it changes its temperature by 1 degree. That means that even if our heating element would be unstable and would sort of fluctuate maybe in the output of heat that it produces, this would be fine and would be sort of buffered out by the water, because the temperature of the water only changes very slowly. A different advantage is, of course, also that normally our heating elements are some solid object, like a coil, and water is liquid. That means if we use the water to transfer the heat to the chemical, then we can make the water, the heating transfer thing, element, basically take any shape. If we put on some flask of some size into the water, then the water will hug around the flask and will be covering completely the surface of the flask at the point where it's submerged. So we don't need to very precisely manufacture some sort of heating element that fits in exactly this kind of flask. We just use the water and it adapts and hugs the surface. This also has the advantage that we need to do less cleanup. Could imagine designing some heating element that has tiny wires and that wind around a lot, such that if you immerse it in some chemical, then it would have a lot of surface area contact with the chemical. But besides all of the disadvantages I was mentioning so far, this also makes it such that we need to possibly clean this heating element. And normally it would be kind of a bad idea to do it in this way, because if you want to heat the chemical like hydrochloric acid, it might dissolve your heating element.